So far in this chapter, what all you guys have studied? See, you have studied about 5 different topics of applications of derivatives, correct? To start off, we started with errors and approximations. You use the concept of derivative to approximate certain values and to figure out how much is the error, correct? That offset whatever you have. To calculate that also, you use the concept of derivative, right? Then we discussed about derivative as a rate measure. See, when you talk about derivative as a rate measure, we always think in terms of the rate of change of certain things, right? So it could be rate of change of volume or area or length, whatever it might be. So here in this concept of derivative as a rate measure, we discussed about how derivatives are used in physics also, correct? Certain problems we discussed. This is another application of derivative which is quite important. Then after that we discussed about increasing and decreasing functions, which is a very important parameter. That is, whenever you have f dash of x greater than 0, then we understood that it is increasing. If f dash of x is less than 0, you know understood that it is decreasing, correct? Now, once you understood about increasing, decreasing function, in which interval it's increasing, in which interval it's decreasing, we discussed that also, right? Moving on, we came to the concept of tangent and normal. See, tangent and normal is that particular, you can say, application where you differentiate at a particular point, you're going to get what is the slope, correct? Once you get the slope, if the slope is positive, then you can figure out what it is, how it is. That is the slope of the tangent, right? And whenever you have a normal, normal is that line which is perpendicular to the tangent at the point of contact, right? To solve any sort of tangent and normal type of question, we used to use the concept of straight lines, which is y is equal to mx plus c is 1, or y minus y1 is m into x minus x1, where m is the derivative, and you're going to apply a value of derivative there, isn't it? This was one. Now, normal, we use the concept of product of the slopes is -1. Then once that is done, we discuss the concept of maxima and minima. Now, whenever we talk about the concept of maxima and minima, remember there are local maxima, local minima, where you differentiate the function, equate it to 0, get the points of inflection, or you can call it as the turning point. Once you find the turning point, then you find the value, do second order derivative. In the second order derivative, if the second order derivative is less than 0, it's maximum. If it's positive, then it is minimum. Then if it's equal to 0, it's neither maximum nor minimum, correct? So based on that, we also discussed couple of problems, right? And these, whatever we have discussed, these are applications of derivatives. Fine. In the next chapter, we look into the next important concept in calculus.